At this point, we have specified the governing equation, including the k and q dot, and let's next specify the boundary conditions. We have convection on the heat sink surfaces exposed to air, and let's impose that. So what I'll do is I will come into, I'll highlight steady state thermal, and I will highlight convection. And then I need to specify the surfaces. So I'll go to surfaces selection filter over here. And I need to select the surfaces corresponding to the gray region. So what I'll do is I will select, before that, I'll say body selection. I'll select that body and I will say hide all other bodies. Okay. And then I will go back to surfaces. And now if I right click, I can say select all. And then this is an interior surface. So I want to deselect that. So if I control click, it'll deselect. So control click is select, deselect. It'll toggle between the two. And you should get 26 faces. This is the convection coefficient that ANSYS calls film coefficient. So that's 12 in my demo. And I'll leave the ambient temperature at 22. So what I'm specifying are H and T ambient. Okay, so the convection boundary condition is specified. Everywhere else we're assuming it's insulated, and that's a default. So I can right click and say show all bodies. And at this point, both the governing equations and boundary conditions are specified. Now we need to obtain a numerical solution. And for that, I need to provide a mesh, and it'll go from the boundary value problem to a system of algebraic equations using that mesh. And what I'll do is to create the mesh, I will just use the default. So I'll highlight mesh in the tree and update or generate. I'm not quite sure, never quite sure what's the difference. Sometimes I have to click on generate to generate the mesh. Okay. So that's a default mesh. You can see it's pretty coarse. For instance, you should have at least 2 elements across the across this region here, across the thickness, whereas we have only 1. And one can go in and play with the mesh settings. There are a lot of settings under sizing and so on. I'll show you an example where that was done. To get like 2 elements for the thickness, and you see you get a lot more elements. I'll show you a different way to refine the mesh. For now, we will stay with a pretty coarse mesh. Maybe we can just introduce just an overall sizing. So I'll highlight mesh in the tree. I'll say sizing, and I will say bodies, select all, or control A. Okay, all bodies, and element size by default is around 7 millimeters. So I will set it to say just slightly lower. I can go lower, but I'll get more nodes, and I don't want to do that in this demo. And then I'll say update. It shouldn't be 6 meters. It should be 6. My bad. So it should be 6 e to the power of minus 3 meters. And then I'll say update. Okay, that's better if I highlight mesh. And I can, turn the mesh on and off. So if I go under geometry and I want to turn off the mesh, I go in here and I toggle between the two. And this quick launch, searching things over there is also very helpful. Okay, so I have the mesh, and I'd like to go and take a look at the number of nodes and elements. So you see I have around 17,800 nodes, and we're telling ANSYS, hey, calculate the temperatures at these nodes. by solving a system of algebraic equations. And you can go in here and highlight the nodes. So let's do that. If I go in and select the node selection filter, okay, I can control click, and I'll see that, you know, those are the points at which it's going to calculate the temperatures directly by solving a system of algebraic equations. And it also has mid-side nodes to get a second order interpolation. We won't get into that over here. Okay, so we have a mesh, and ANSYS can now generate the system of algebraic equations starting from the boundary value problem and get the nodal temperatures. Let's get it to do that. Before that, it's a good idea to save the project. And if you're the praying kind, say a prayer and hit solve. This is where it's generating the algebraic equations and inverting them, you know, around 17,800. And if so now I have all the nodal temperatures, all 17,844 of them. And let's do the post-processing. So now we are, you know, we have the nodal temperatures, and we'll do the post-processing. And the first thing you usually look at is the temperature distribution. So I'll say thermal temperature. So highlight solution in the tree to get that. And then I'll say evaluate all results, because that's ANSYS terminology for post-processing. So it interpolated the temperatures at the nodes to generate this plot. And I can go in here and say no wireframe. I can make it smooth contours to improve your boss maybe. And you see that the range of temperatures is from 34 to 44 Celsius for these you know, for these inputs that I've selected for the demo. And the other thing that's interesting to look at is the heat flux. So I'll say total heat flux, thermal total heat flux, and again, evaluate all results. So this is gotten by differentiating the temperature field. And you can see that, you know, you can see the distribution of the heat flux. The heat flux actually is better visualized as vectors. So you can say vectors. You can play around with these settings. You can make the vectors a little bit longer. And if I come in here, I see, you know, I can see how the heat is flowing. It's pretty cool. And you can see, you know, past around here, there's not much heat that's flowing out. So maybe I can cut this, you know, cut the length of these fins. And the other nice thing is you can look at heat flux vectors in the interior. So what I'll do is I will click on Z here, translate it, and then go to section plane. And I will take a cut like that. Okay. And now what I can do is I can look at the heat flux, how the heat is flowing in the interior. It's pretty cool. And I can also do this for the mesh. So if I go to the mesh, I can look at the mesh in the interior. You can move the section plane by, you know, selecting this option here. And you can also show whole elements. So if it cuts through an element, it'll show the whole element. So these are all kind of very nice options to look at the interior of the model. So I'll just say deselect that, deselect the section plane. Actually, keep the section plane, total heat flux. Now, if you want to, you know, capture a snapshot of that to include in your report, what you can do is you can just, there is an option here to save. might be under display. You'll have to kind of they've moved it, so I don't know off the top of my head, but there's a way you can save your your whatever you have in the image. You can of course also use the snipping tool in Windows. So if you say snipping tool, and then you can, I just need I can draw that and then I can save it and so on. Okay, so those are some of the things I wanted to show you. So what at this point, maybe you can go back here to the Workbench window and say File, Save, and File, Archive, and download that archive. I will replace it and I'll say select everything and archive.